In this video, we're going to be connecting AMS to a Samsung 3731-3 positioner. So we've got our valve actuator positioner here in front of us. We have 30 psi supplied to the positioner. So we've got 30 psi here coming out through a regulated air supply here, and then it flows over into the top port here on the positioner, you can see. We also do have this three-way ball valve connected here. What this allows us to do is, if we wanted to use a pneumatic instrument to control this valve, we can turn the valve here this way, and now our pneumatic signal can come in and will flow directly into the actuator and control the valve. Since we want to use the signal out from the positioner right here, it's going to flow in and out to the actuator here and control the valve up and down, just because we're using this positioner here. So our supply pressure goes into the positioner, and this is our signal coming out over to the actuator. So just wanted to explain that valve, make sure that it's orientated this way for the positioner to work properly. Next off here on the training equipment, you can see we have some of the wiring broken out here. We're gonna be working with the plus minus terminals here, and they're just located. Let's take the cover off here. It's been broken out from right here. You can see the signal there. There's the signal wiring there, plus minus, red being positive, black being negative wire there. They're broken out here for us. So the first step here in our lab, what we want to do is we want to make sure that this valve is working. So I've got a fluke 725 right here. It's sourcing a milliamp value out here. To get it to source, I'll just start it from the beginning here, power it on. And what we want to do is press the measure source button here to toggle to source. Make sure that we've got our leads connected here, and we also need to make sure that we have a 250 ohm resistor. We're going to be using this later to communicate through HART protocol to the positioner. So I'll increase this to 12 milliamps. So we're sourcing 12 milliamps, and what we should see now is our display up there, LCD display, should now be reading some numbers on it saying test. It's doing initial startup, and the valve here should go to 50% open. You can see on our indicator right here, when we carefully don't get our fingers in there, but on our indicator there, it's at 50% open at 12 milliamps with using a 4 to 20 milliamp signal. So we verified that. Next up, we're going to be connecting up to the positioner with AMS. All right, so now what I've done is I've started up one of our laptop computers with AMS on it, using the virtual machine. It's installed in the virtual machine here. So if you don't remember how to configure that and configure the Viator HART modem here to communicate to our Samsung positioner, you'll need to check that out in our other videos on AMS, where we connect the Viator modem here to talk to a Rosemount 3051 transmitter. Just to show you where it's connected here on the valve, the HART modem, the positioner, there is no hook terminals here, but there should be some bare wires exposed on both the positive and the negative, and as long as we have our 250 ohm resistor connected in series, we can then connect these hook leads across the bare portion of those wires. You can see here's our 250 ohm resistor, and then we should be able to communicate with the positioner. So what I've done here is I've logged in to our virtual machine with AMS on it, and I'm just going to show you what I added. Now that I had to terminate the servers and add the HART modem to network configuration here, so I don't think I'll be able to open it right now. I'll probably get an error. Oh no, it did let me open it. Yep, so you can see I have HART modem 1 there added, so that needs to be done. If it's not there already, it should be gone because we restored snapshot at the end of the last session with this. So now I'll open up AMS Device Manager, and what we're going to do now is we're going to confirm that we are communicating with our positioner up there. So it's just opening up, and we're going to go over to physical networks here up in the top left. So I'll drill down. We'll open up the workstation, that'd be this computer, and then the HART modem right there, and there we go. There's our Samsung valve is showing up there. It's got a default name of the date and time. So what we're going to do next is we're going to play around with this and play with some of the diagnostic settings that the positioner has with AMS. All right, so now that we're up and communicating here, the next thing we want to do is we want to just kind of show what AMS allows us to do with this valve here. We're going to double click on the tag. It's going to open up the overview screen for AMS Device Manager here, and we want to, one we're particularly interested in this lab is Device Diagnostic, so we're going to click on that tab, and because we've got this, we're just going to play around with it just to see what it can do for reliability and maintenance purposes here for our valve. So it's communicating with the device. We're using the HART protocol. It's a little bit slow, so it does take a little bit to grab data from the device. So right now it's loading everything. What we're going to be after is some of the, I'm going to demonstrate. I wanted to show the status messages here up in this tab here. You can see there are all these check boxes here, and these are the possible status messages that this valve can throw if there's a problem with it. So once this all loads up here, you can see that it goes, there's 0 points, fatal error, data memory, test calculation. All these messages are more of a description stated in the manual for the valve, and we're actually going to be looking at one of these error messages in our next task in this lab. So I wanted to point those out. The other thing here is the statistical information, and this is what we're after right now. One piece of information that is pretty helpful is to know where that valve position has been hanging out, where the valve, where it's been traveling to. Is it fully open? Is it fully closed during normal operation? So what this will do is it'll pull data points to produce a travel histogram to show you where the valve is most commonly, what position it's normally in. So once that loads, we'll have a look. Oh, that was faster than I expected. So here you can see I had the valve open for 75% for a while, and so you can see some of our data points reflected that. We've got a little bit of frequency showing up there, but our highest frequency here is at halfway at midpoint, and that's where we have the valve set at right now. As it's at, you can see right there on the LCD, it's saying 50%, and I've got 12 milliamps over here on the Fluke 725. So if we were to change it, we would probably see, if we were to change it, maybe we'll put it down to 25% here, and we'll just see, let's drop it down to 8 milliamps. And right now it's sampling, it's the data here, it's got 962 measured points, and it just updated there again. It might take a little bit, but once it updates again, we might start to see a little bit of something showing up down here around that 25%. About 30 seconds or so, and now you can see that it is showing here some occurrences or frequency. You can see on the y-axis frequency here of percent frequency showing up at 25%. So there's going to be a question in the lab on how this might be beneficial to the technician that's using this software. All right, so I just opened the valve to 100%. It's at 20 milliamps being sourced to the valve. And we should see our travel indicator there should be indicating it's 100% open. Up here it also says 100%. The next thing we're going to be doing is simulating how AMS can flag an error if there's something, say, down in the valve here, down in our valve body in the globe valve. There's a plug and seat inside of here, and the plug comes down to close off the valve. If there is, say, a chunk of or a rock or some metal or something in there that doesn't allow it to close all the way, I wanted to show how this smart device can actually detect that and throw an error. So we can kind of pinpoint what we need to fix. If we had 100 valves on site and one of them threw this error, we would be able to quickly find it and fix it, and it wouldn't go unnoticed for a long time. So I've opened it all the way. The next step here to simulate that we've got this plugged off is I'm going to be putting, I've got a 9/16 wrench right here. I'm going to be 9/16 wrench. I'm going to be putting in here and closing the valve on it to show that the valve is still open, but the position over here, the positioner would be trying to put it to 0. So I'm going to go ahead and do that. On the meter over here, and the valve here has the wrench stuck in it, and it's showing that it's 20% open still when it should be at 0. All right, so the first thing I noticed, you can see there's a little wrench right under the 2 there that's appeared. That's just to give us a quick indication that this thing needs maintenance or service, needs to be checked out. And if we look here now, this 0 point is checked off under our status messages, and that there indicates that yes, that there is an error that's occurred, and it was at the 0 point, something to do with the 0 point. So if we looked up in the manual, it would probably describe that the valve must be stuck open or something like that. So there, that shows how AMS the positioner can figure that information out, and then we can view it through AMS. So we could set an alert monitor or something like that to alert the user that this valve needs to be serviced. And so what I also wanted to demonstrate here is I set up the alert monitor here, and you can see right now it's throwing an alert, and it's saying that it is an abnormal for severity, and then under more description it says more status available. So if you were to double click on this, it's going to open up the device, and then we'd go down to Diagnostics here, and if we go to status messages, then that's where we would see our 0 point issue. So the powerful thing here now is we set an alert monitor, throws an alert. We double click our status messages, we have a look, and this error code shown here, and we can look it up in the manual and find out what the problem is so we can quickly address it. So that's the power here of AMS and the smart devices here. They can kind of troubleshoot themselves, and it speeds up a lot of the time here, and we can save a lot of money by not having to do all that extra work manually. So one other powerful tool here that relates to what we were just doing with the wrench in the valve. And one thing I wanted to point out is we will not be using the wrench in the valve demo in the lab. We'll be doing something different, so it'll be something new to troubleshoot, just because the wrench in the valve is kind of a little bit of a hazard. We don't want to be sticking anything in that pinch point. We could be pinching our fingers, or the wrench could come loose and fly out at us. So the other histogram I wanted to point out is the set point deviation histogram. So we're going to click on that, and that should bring up, it's going to show us the deviation from the set point. So that means when we had our valve up there, we wanted it to be 0% open or closed all the way, and we're at 21%. It's going to show us, we should see something happening here on our graph. And I'm just going to scroll down. If you have a look, this is ideal. We want to have 0% deviation between the set point and the actual position. But over here we have some of this stuff showing up, where we had we have this negative deviation. And so that there has to do with our wrench stuck in the valve. That's why we had that deviation. If it was from the start, if we would have shown this before, we would have saw probably no deviation. Most of it would have been right around 0% because the valve was functioning correctly. So this is also a powerful tool. It will show us how often the valve position matches the set point, and we want it to be pretty much most of the time. So we'd like to see a high frequency here, right around 0%. Right, so I just did a quick search. We have our manual here, type 3731-3 positioner, and I've already searched here in the document. I searched for 0 point, and it found it, and there's this table right here. Oops. So you can see the table right here. This is the operational errors or malfunctions code towards the end of the document. And right here, 0 point error code, incorrect zero position. Error can occur when the position or attachment position is shifted or when the valve trim is worn, particularly with soft sealed plugs. Maintenance required. Recommended. Check valve and attachment positioner. So that's the first thing we want to do. We want to check to see what's going on with that valve. And there just so happened to be a wrench stuck in it. So we remove that wrench, and the 0 point message can now be reset. And so just like at the end of the other labs, what we need to do is to finish up here. Basically, we can leave everything open, and we just close our virtual machine right here, and it's going to prompt us. It's going to say power off the machine, restore current snapshot, IET 235. We'll check that on. It's going to clean out everything that we did, put it back to normal, and our manuals and stuff are just left over here. But now everything's reset back to the way it's supposed to be. Snapshot's restored, and it's ready for use by another group.